This video is about the domain of a function, and for our notes we'll get a general definition here, which is that the domain of a function is the set of all its possible input values. So input is the key word here. And we say that a domain is all real numbers excluding any which can cause. As you may recall, we've seen this before with expressions. We can't divide by 0, and we can't take the even root of a negative number, at least within the real number system. And so those two conditions are where we'll look to find values to exclude from all real numbers for a domain of a function. Now, these are only two possible cases we have to exclude. This list will definitely grow as we add more types of functions later on. Let's look at an example where we want to find the domain of the function and express it using interval notation. Our function reads f of x equals the square root of 4 minus 3x. Anytime we're evaluating or finding a domain of a function, we have to consider the cases where we have to exclude values. For instance, might we be dividing by 0 in this function? Well, there's no fraction involved, which means no, we're not going to divide by 0, so we can ignore that condition and move on to the second. Notice this is a square root, and the second condition is that we cannot take the even root of something negative. That's possibly applying in this scenario. So what that means is that what's underneath the root, in this case 4 minus 3x, we have to make sure that is not negative. Well, another way to say that is to make sure that 4 minus 3x is greater than or equal to 0. That would mean not negative. Now we'll just solve this inequality to see which values of x we would like to have. In doing so, we would get negative 3x is greater than or equal to negative 4 by subtracting 4 from both sides. And then if we divide by negative 3 on both sides, recall all the inequality steps here where if you're dividing by a negative, you have to flip the inequality. That means now we have x is less than or equal to positive 4/3. So let's kind of follow this all the way back. When x is less than or equal to 4/3, that means that what was under the root is not negative, which is exactly what we need for values we're allowed to have in our domain. So we're going to write this in interval notation now. If x is less than or equal to 4/3, that means our domain would simply be from negative infinity all the way up to 4/3 with a bracket at 4/3 given the inequality symbol we see. And so that's what we can say for our domain. Nothing else will cause a problem because we know we didn't have any division by 0 possible. This was our only concern. Let's consider another example where we want to find the domain of the function and express it using interval notation. This time our function reads f of x equals, now it's a quotient where the numerator is x cubed minus 8 and the denominator is square root of 8 minus x. Now let's again consider our two conditions we look to exclude in domain at this point, which is number one, we can't divide by 0. Well, there is some division going on in this function. As you can see, there is a denominator, and that cannot be 0. Well, we can find out when that might happen by setting it equal to 0. So we'll just take our denominator, which is the square root of 8 minus x, and set it equal to 0, and solve to see when or which x values might cause this. We can go ahead and square both sides of this equation to solve, and we'll end up with 8 minus x on the left side and then 0 squared is 0 on the right side. If I add x to both sides, I'll simply get 8 equals x. In other words, let's run this back through. When x is 8, our denominator would be 0, and so we have to exclude that value for x. We're not allowed to let x be 8. We'll keep that in mind as we construct our domain. Our second condition to consider, which also does apply in this example, is that we cannot take an even root of something negative. Well, that means that what's underneath the root in the denominator, which is 8 minus x, that has to be greater than or equal to 0 to avoid it being negative. If we solve this for x by adding it to both sides, we'll simply have 8 is greater than or equal to x, or you could say it as x is less than or equal to 8. So we have to put both of these conditions together in summarizing our domain, which we'll now do in interval notation. So if x has to be less than or equal to 8, that means we could start at negative infinity and go all the way up to 8. Now we have to be careful at 8. The second condition of making sure what's under the root is greater than or equal to 0 was actually an inclusive inequality where x could be less than or equal to 8, but our first condition of the denominator not being 0 meant that we had to exclude when x does equal 8, or we could say x cannot equal 8. So that means that the boundary symbol at 8 actually has to be a parenthesis because we're not supposed to include 8 in this set. This interval of negative infinity to 8 with parentheses on both sides will then summarize both conditions and represent our domain in interval notation. Let's look at a third example where we want to find the domain of the function and express it using interval notation. This function reads f of x equals, it's a quotient where the numerator is x plus 4 and the denominator is x squared plus x minus 6. Now, given that this is a quotient, our concern is that the denominator is not equal to 0. In other words, we have to exclude any values that might cause that to represent our domain. Notice there is no root or even root in this function, so we don't have to worry about that condition at all. We'll simply worry about when we might be dividing by 0. Now, to find out when we might be dividing by 0, we'll actually take our denominator of x squared plus x minus 6 and then set it equal to 0. Remember, this is what we don't want, but we have to find out when it will occur so we know what to exclude. We'll attempt factoring to solve this. Any other quadratic method could work for solving, but this one is factorable, which tends to be the quickest if it's possible. I think x plus 3 and x minus 2 will do it for us here. We'll now set each of our factors to 0, which would yield x could be negative 3 or x could be 2. Now remember, when x is these two values, that means our denominator is 0, which is actually what we want to avoid. So what this really means is we don't want x to be either negative 3 nor 2. So let's go ahead and summarize our domain in interval notation by saying everything except those values. Well, we'll start all the way to the left at negative infinity. We'll move up until the first of these we hit, which would be the negative 3. We want to exclude it, so we put a parenthesis, but then we union to hop right over it and continue. We want to go then from negative 3 until the next value we want to exclude, which is 2. Excluding both with parentheses, and then union the rest of the real number line, so 2 to infinity. This interval represents everything except the values negative 3 and 2, which is our domain for this function. For our next example, we also want to find the domain of the function and express it using interval notation. This time our function reads f of x equals x to the 8th power minus 42. Now we'll consider our two problems for domain. Are we at risk of dividing by 0? That's one of our concerns. In this case, there is no division or fraction, so we could say no, we're not going to do that, which means we don't even have to look for it. And secondly, are we in danger of taking the even root of something negative? Well, in this function, there is no root nor even root, so we're not in danger of that either, which means if neither condition applies, our domain is automatically all real numbers. We'll simply say negative infinity to positive infinity.